Hello and welcome. This is the Quickstart for Parigot. I am Ian Smith, and Parigot is open source software that you can get at the GitHub URL below. This is a quick start for microservice developers and software managers. So you might be asking yourself, what's the hard problem here? Why does Parigo exist at all? Well, it's because building applications that are based on microservices is much harder than building a single application because now a microservice application is a distributed system. This quick start is going to cover one particular feature of Parigo, which is the ability to run all your microservices inside a single program or a single process if you prefer. For this quick start, we're going to use, of course, the Hello World program and another program you'll see later. Since we're using microservices, of course, we have to have two services that are communicating, and one of them is the Hello World program that prints out a greeting, and the other one is a greeting server that can respond with the greeting for a particular language. Okay, so we're going to assume that you've already cloned the repo here. I'll show you that I've cloned the repo as you'd expect from its repository on GitHub. We're going to start by just running VS Code on the workspace that we've provided. This just gives you all of our settings and colors and stuff. You can change that if you want. But when you power it up, the most important thing is this box right here, which is telling you that there's a dev container. And in fact, you can open the project inside the dev container. So what's happening now is it's starting the dev container, which it now has started up. And that container is actually has all of our tools and all of our environment variables and everything else already configured, and it's built for building the example programs as well as Parigo itself. So just for giggles, we will do make clean and make to show you that we can build all of the sort of system software pretty quickly. It's only between 15, 20,000 lines and another 10 or 15,000 lines of generated code, which is a separate thing. It worked, as you can see, we built just fine. So let's go to the example Hello World. As you remember, we showed you the graphic just a minute ago of the architecture. Well, you can do the same thing here. You can just rebuild it and then clean it, then rebuild it. And as you can see, it builds quite quickly because you have already built the Parigo infrastructure. So just to make it as exciting as possible, let's just start by doing runner, and this is going to be hello world.toml. Now that file, hello world.toml, is a configuration file for deployment. We can discuss that more later, but what this is doing is that runner is being used to run the program, and it's using this configuration file. And let's look at this output line by line, and this is a structured log, so it's a little bit harder to read. But you can see right here, hello world launched successfully. Then you can see greeting service launched successfully. And then, in fact, it asks for the French greeting and the service 4465, which is also right here, 4465, is the hello world. And the hello world service put out a message. And then it says, hello world completed successfully. So that's pretty much what a hello world program should do. A couple of things worth noting is that the host IDs of these are different. That's host 1118, and this is 70B7, and those are really not hosts that you think of. Those are hosts in the virtual world of Parigo because, in fact, these are all running inside the same program, so there's not much reason to change it, to have like IP addresses and things like that, because it's literally running within the same address base. So what we'll do, just to prove to you that this works, is we will do code main.go. Whoops. Oh, we've already got that up. And if you look for the word French, you can actually see it right here is the greeting request, which is, we'll show you where that came from in just a second. But let's do tongue German. Sure. Okay. Now we'll just rebuild everything because it's fast, and then we'll rerun it, running with the hello world configuration file. And it says, this time it says Guten Tag World, because that is the German. So that should show you that we're at least not, faking this whole demo. The other thing to be aware of is that these programs, this program runs into completion, which is a little bit unusual. Usually, microservices, when they're built for an app, don't run to completion. They just are. You just deploy them and launch them, and all the services just stay out there. But you can configure that in the TOML file to say whether you expect this program to run to completion or not. So also notice the services are different the second time we've run it, hosts are different, and so forth. So let's go and do another test let's look at HTTP Simple, which is another little program. So just to explain the HTTP Simple app, you'll notice that it is two parts. One part is the front door service that accepts incoming traffic from the internet, and the other service implements a particular handler, in this case for GET, and it responds with the necessary information for sending the data back to the customer on the internet. Returning to our actually dev container, we're gonna make sure we're in the right place, which we are. It's in example HTTP simple, and we will rebuild HTTP simple, and then naturally we will use runner HTTP simple.toml, the configuration file. And in this case, you'll see that the front door service launched successfully, and it gives the service ID and the host. Similarly, simple service launched successfully. So both of those are just services that are out there in the world. So let's open another shell here, and we'll do curl HTTP to localhost 9000, which is where it's sitting, and we'll do foo bar baz. And this is the response of the simple server, which says hello HTTP protocol and tells us that it got a get message, and this was the URL. And of course, you can do that as you want. But what's maybe more interesting to some folks is what's going on back in the other shell, which is you can actually see this is actually the front door telling us about the HTTP level things that are happening. This is status 200. How many bytes did we send? What method is it? What's the URL, etc., etc. This is just a little log of what the thing is doing, but it might be interesting to you to try to break it a little bit, because we've only got a handler for get. So what if we do that? It says not permitted, you jerk. That is because we don't accept posts, and we can even show you that it's doing its thing at the correct level of HTTP. If you're familiar with this, you can see sending post to the particular URL, and then what's happened is when it comes back, this is me playing with the headers to just tell them to try a different verb. And you can see an HTTP 1.1 request of a response of 401 unauthorized, and then this is the body. So that service is serving data from the internet, but it's worth thinking for just a second about how that works in a world where the particular services are bound to these virtualized hosts, because you don't really have access to port 9000 on a particular machine when you're running inside the same process as somebody else who's kind of on some other host, but in theory, at least, they should have access to that too, right? So in fact, neither of them have access to it, and the HTTP infrastructure of parigot routes these requests exactly as if they were parigot requests from the get-go. So HTTP protocol looks exactly like Paragot's protocol. So just for instance of showing you that, we'll go back to hello world and maybe do greeting.proto. Okay. So this file is in protobuf format. If you're not familiar with it, it's really popular definition language. And as you can see, the service is defined right here. It's service, greeting service. We're telling it we have this is a parigot specific option, but doesn't break other systems, which is that we have a special error kind called greet error. And here you go. We've defined that fetch greeting takes fetch request and fetch response. And if you go down a little bit, oh, by the way, here's the definition of tongue, which is an enum. But similarly, greet error, and now the greeting request has one thing in it, which is a tongue, and the response has the greeting in the particular language. So that is how you do it. Everything in Parigot is defined by .proto files, including Parigot itself. So you use these proto files to know how to get the call response to work. So it's worth also noting for the careful person that if we go, like, for example, over here and do make clean make, you'll notice that the build command here includes this piece of information right there. And that, if you're not familiar with it, means that the Go compiler should generate WASM code. You can look up what WASM is. It's WebAssembly. So actually, the programs that we're reading, or the services definition and the code for them, is actually in a WASM file. So in fact, it's not a binary for the host system. This has the advantage of making Parigot programming language neutral. Although everything you've seen here has been in Go, there's no real reason you couldn't do it in other languages, so long as they can output WASM files, which these days pretty much any language can. So that means that with that independence, plus doing everything in .proto files, where you can generate the bindings for, I don't know, about 30 different programming languages. So in general, Parigot doesn't really care how you run your program. You can run it, you can do Rust, you can do Zig, you can do JavaScript, you can do whatever, Java, and all of them will work the same way, although I just use Go because I'm the most familiar with it. Thanks for your time. We really appreciate it. We know you're all busy. Please get in touch if you have questions, concerns, whatever. Please get in touch by any of those mechanisms I put on screen, and all of the information you have seen in this video is related to the Atlanta 0.3 release, and we'll probably have to record more videos for future versions. But thanks. Bye.